Hi, my name is Trevor Arndt. This is my video lab report for Lab 1, the charge tapes. The goal of this lab was to calculate or measure the amount of excess charge in an ordinary object. This lab focused mostly on the physics principles, electric forces, and fields by using Coulomb's law to calculate both of these principles. The coding portion of this lab used two different strategies to create two different models of the interactions happening in this lab to calculate two different amounts of electric charge. The physics principles included in this lab include electric field. An electric field is a principle of a charged particle in space. The particle creates a field of electricity, which creates a force when a particle is placed within it. This electric force can be calculated by using Coulomb's law. The force created by an electric field is dependent on the magnitude of the charge and the distance from the charge to the source of the electric field. Over here, I have Coulomb's law, and here I have a diagram of electric fields, which create the electric force. The process for this lab. To conduct this lab, we created two pieces of charged tape by quickly removing the tape from a flat surface to charge it, which is in figure 1. We then hung the charged piece of tape between two raised objects to create a gap that the tape would sag into. This sag is because of the force of gravity, which pulls downward on the tape. We then charged another piece of tape and put it close enough to the upper piece of tape to observe the upper piece of tape floating or opposing the force of gravity. This is pictured in figure 2. The reason the tape was able to do this is due to the electric force which acts on the tape upward, opposite of the force of gravity. When the electric force was greater than the force of gravity, the tape moved upwards. After seeing this result, we modeled the interaction in GlowScript in order to calculate the electric charge necessary to cause this. Here are my results. Some assumptions that we made in the experimental portion of this lab. I assumed that the upper tape is the system, the lower tape is in the surroundings. I assume that hands do not affect forces in the experiment. I assume that each tape has the same charge and the interactions between the charges happen at the center of the tape. These are the results for the experimental portion of the lab. My tape was 0.2 meters long, had a mass of 2 × 10⁻⁴ kilograms. The distance between tapes when floating was 2.54 × 10⁻² meters. The magnitude of the gravitational force was 1.96 × 10⁻³, which is the same as the magnitude of the electric force, although they pointed in opposite directions. The measured electric charge on the floating tape was 1.19 × 10⁻⁸ newtons per coulomb. Here are my results from the coding portion of the lab. My first model assumed that the charges were point charges in the center of each tape, and that the charge in it, I got a result of 2.39 × 10⁻⁸ newtons per coulomb. My second model assumed that there were lines of point charges distributed evenly across the tape, and I got a result of 3.97 × 10⁻⁸ newtons per coulomb. Here are a couple coding assumptions. Oh, well, I already said that. Here's an overview of my code. The first one, I used the function for an electric field that we created in lab 0 and got my answer off of that. The second code, I just edited the lines where we were told to, and then manipulated the electric force found in the first model to match the magnitude of the gravitational force. Here are a couple of conclusions that I made from this lab. If protons were negative and electrons were positive, this lab would give the same results because of how the electric force works. Both tapes have the same type of charge and same amount of charge, therefore the tapes repel each other. It doesn't matter the sign on the charge as long as they have the same sign as well as the same magnitude. The two results that I got for the amount of charge on each tape were different in each of the codes. Here's a little refresher of the values that I got. And the reason for the differences in these calculations is because of the different assumptions we used. The first code had the assumption that the electric force was caused by point charges in the center of each tape. Second code used the assumption that the tapes were lines of charges, the amount of charge, and the second code had to be larger than the amount of charge in the first code because the charge was treated as line. Therefore, it was distributed over a larger area, which caused it to be further on average than the first code. And some possible error that we could have had in this lab could have been human error in my measuring between the distance of the tapes, or in GlowScript when I was writing the code, because I am unfamiliar with Python. And that concludes my lab. Thank you.